This video is about Rolle's theorem and the mean value theorem. So we're going to start with Rolle's theorem. So for Rolle's theorem, we need a function that is continuous over a closed interval and also differentiable over the interval. You'll notice that one of them is closed, one of them is open. We actually don't care about the endpoints being differentiable. So what we are going to say is that if the y values at our two endpoints of the interval are equal, then we are going to have at least one x value in our interval where the derivative at that x value is equal to 0. So I'm going to draw a picture and then we'll do an example. So take a look at this picture. You'll notice that we have a function that is continuous between x equals a and x equals b. The other thing on this function, it's not drawn perfectly, but hopefully you can see for the most part that what I'm getting at is that the y value when x equals a and the y value when x equals b are equal. So that's going to be our f of a and f of b. So here we see that f of a is equal to f of b. That's the first thing that we have. So we've satisfied all of our conditions that we need. So then what we're going to find is that we do have at least one value, I'm going to call c, where the derivative is 0. And actually, if you look at the very bottom of this, you can see I have this valley here. That is a relative minimum. It's actually the absolute minimum here. And that one has a derivative of 0. We know that because if we were to draw a tangent line there, it would be horizontal. So at this point, our derivative is 0, and we're going to call that point c. So we say f prime of c is equal to 0. So here's our first example. We are going to show that Rolle's theorem applies to this function, f of x equals x squared minus 3x plus 2, over the interval between 1 and 2. And this is asking you to find the value of c guaranteed by Rolle's theorem. So the first thing we need to do is we need to show that Rolle's theorem applies. And to show that Rolle's theorem applies, the first thing we need is we need it to be continuous. And you'll notice that our domain of this is all real numbers. It actually does not need to be all real numbers as long as it's continuous on this interval. The other thing is it's differentiable, and it's actually differentiable everywhere. If you know what this one looks like, it's a parabola, and parabolas do not have any corners or cusps or asymptotes or anything like that. So it is going to be differentiable over that interval. The last thing that we need is we need f of 1 to be equal to f of 2. So those we have to actually check. If you try f of 1, you do end up getting that your value is going to be 0. If you try f of 2, you end up getting hopefully the same thing. We find that we get 4 minus 6 plus 2, and that's also 0. So f of 1 is equal to f of 2. So this is showing that it applies. The next thing that we need to do is we need to find c. So we're going to find c where such that the derivative at c is going to be 0. First thing I'm going to do is I'm going to find my derivative. Derivative is 2x minus 3. And then I need to figure out what c is. So all I need to do is I need to set that equal to 0. I'm going to find that x is going to be 3 over 2, and that actually is my c value. So that's all you usually need to do for Rolle's theorem. So the second theorem is the mean value theorem. Actually, the mean value theorem is a more general version of Rolle's theorem. Rolle's theorem is a specific example of the mean value theorem. So we have the same conditions. We need our function to be continuous and differentiable. what this is going to tell us that is that there is a value c where the derivative is equal to the average slope. So basically what's going on here is this f prime of c is going to be the slope of the tangent line. This right here is going to be our average slope, and it's actually the slope of our secant line. So now you probably have heard the word secant used several places in math. This is not the secant that's the 1 over cosine. I'll draw a picture for you so you can see what's going on here. So here I have a function. You can see that it's continuous. There's no weird corners, there's no cusps, there's no places where it's undefined, so it is differentiable. So what this is going to tell us is that there's a place where the slope of the tangent line is equal to the slope of the secant line. Okay, so for right here, we have this line right there. This point right here is our x value is b, our y value is f of b. This point right here at the bottom, our x value is a, our y value is f of a. So the slope of this line is going to be y1 minus y2, which is f of a minus f of b, over x1 minus x2, which is b minus a. So what the mean value theorem is telling us is it's telling us that we have a point along this curve, which is the function I have in black, that actually gives us an equal tangent line to that. And so I'm just going to kind of take a guess. You might be able to guess better than me, but it looks to me like it's about right there. And this is the slope of the tangent line. And I'm going to call this point C. And so the slope of the tangent line is the derivative of that function evaluated at the x value c. We're just going to do one example that uses the mean value theorem. So this one specifically says determine all values of c that satisfy the mean value theorem for f of x equals 5 minus 4 over x on the interval 1, 4. So this one, before we actually do the problem, we have to make sure that we can use the mean value theorem. And you might realize that this function is not continuous. It actually has an asymptote at x equals 0. However, we don't really care about what the function looks like at x equals 0 because our interval is only between 1 and 4. So it is going to be continuous, and it's a rational function. It doesn't have any weird cusps or corners. So it's both continuous and differentiable on that interval. So it does satisfy that. So then we are allowed to use the mean value theorem. And so what we're going to do is we are going to figure out the slope of the secant line, and then we want to figure out where the tangent line has the same slope. I'm going to draw like a little picture of it for you just so you can see what it looks like. So it's kind of like this. And we are only looking at our graph between the points x equals 1 and x equals 4. What we want to know is where is the slope of the tangent line in that interval going to be the same as the slope of this green secant line. And you might actually be able to look at it and see that there is going to be a value where it does work, which is good. We want the mean value theorem to be satisfied. So before I find that, I need to find the slope of that green secant line. And that is going to be f of 4 minus f of 1 all over 4 minus 1. So f of 4, if you plug it in, you are actually just going to get 4. F of 1 just gives you 1. That's just a coincidence that it gives you that. The answer for the slope of the secant line is 1. So then we're going to figure out, we're going to find C, and I'll use another color, where our f prime of C is equal to 1. So now we're going to find the derivative of the function we have up above. So our function is f of x is equal to 5 minus 4 over x. I'm going to rewrite that as minus 4x to the negative 1. So my derivative of that, derivative of 5 is 0. And the derivative of negative 4 to the negative 1 is going to be 4 times x to the negative 2, which is going to be 4 over x squared. Now we just need to figure out where that derivative equals 1. So we're going to set that equal to 1. We get x squared equals 4. If you take the square root of both sides, you get x equals plus or minus 2. So we actually don't have two answers here. If you look above, you'll notice the interval is only going to be our x values between 1 and 4. So we're only going to use the positive one. So it's actually going to be that C is equal to positive 2. And just in case you want to see that on the graph, you can take a look at 2. What you're going to find is actually at 2, 3. It might not look like it. And if you were to draw the tangent line of that, it should have the same slope as the line that you just drew, which is the secant line. And for these problems, actually, they only want you to find C. You don't need to do anything else. And this is the most common mean value theorem problem you're going to get, is just going to be to find C.